Good morning to all. I am very happy to invite each one of you, to the program organized by Department of Mathematics, Mahatma Gandhi College, Iritty, in association with the Bhoomithrasena of this college and IQAC of Mahatma Gandhi College, Iritty. This program is part of the week-long celebrations in connections with the Environment Day. Each department of our college organize various programs in this regard. In this program, not only the students and teachers of Mahatma Gandhi College, Iritty, but also students and teachers of other colleges also join. Especially the students of SES College, Srikandapuram, and faculty members of SES College Mathematics Department are also part of this program. I am very happy that today's resource person is an eminent mathematician and who also know how to apply mathematics in various fields. We will see that how mathematics have a role in weather prediction like that. Today's topic is modern weather forecasting, a mathematical perspective. Today's resource person, Dr. Shahul Hameed, sir, is an eminent mathematician. He is a research guide of Kannur University. He published more than 16 journals. 16 publications are there in his name in various international and national journals. He presented so many topics in various international conferences, and he is an eminent resource person. And he also knows how to introduce mathematics to a common person. He is a very friend of mine and also the colleagues of the Department of Mathematics at Mahatma Gandhi College, Iritty. I, on behalf of all, welcome Shahul Hameed sir to say and present the topic, and over to Shahul Hameed sir. Shahul Hameed sir is now the associate professor and head at Krishn Menon Memorial Government Women's College, Kannur. He has more than 27 years of teaching experience. He started his career as assistant professor at NAM College, Kallikandi. Later, he joined at government service and he started his service from Department of Mathematics, Government College, Kasaragod. Later, he worked for various years in Government Brennan College, Thalassery. And shortly, we expect that he will become the principal in one of the government colleges in Kerala. He is also a person eligible to become the professor, and because he has so many research publications in his name and so many research students are under his supervision. I welcome Shahul Hameed sir to this program. And I also welcome all my dear students and faculty program. And I invite Shahul Hameed sir to present the topic. Thank you, sir. Thank you all.
Respected Head of the Department, Dr. Mon, Bhoomithrasena Coordinator, Priyanka ma'am, and all other faculty members of the Department of Mathematics of MG College, Iritty, SES College, Srikandapuram, my dear students of MG College, Iritty, and SES Srikandapuram, and many others who are participating in this program. First of all, at the outset, I must thank MG College, Iritty for inviting me to share some of my observations regarding how we can apply mathematics in various branches of discipline of knowledge. And today I have selected something related with environmental sciences, namely forecasting, weather forecasting rather. So I'm very happy to share what I have learned, as atmospheric science was one of the subjects which I loved apart from mathematics. I lost an opportunity of doing research at IIT Kharagpur in atmospheric science way back in 1993. That sorrow was there with me. So I always look at the news about climatic changes and weather conditions very often. So that's why I selected this topic for the discussion. So let me share the screen, because already it is 11:23. We have to start at 11 o'clock. So let me share my screen now. Dr. Biju, is it visible now? Is it visible? Anybody? Is my screen visible there? Hello? Anybody can respond. Hello?
Sir,
Is it visible?
sir,
Screen കാണുന്നുണ്ടോ? കാണുന്നുണ്ടോ സ്ക്രീൻ?
സാറേ ഇവിടെ സ്ക്രീൻ കാണുന്നുണ്ട്.
Okay. Let me start then. Okay. So my topic is modern weather forecasting, a mathematical perspective. So what I will do is, because the audience consists of many types of, people, just from the first year till to the PG and faculties and all, a general perspective will be discussed rather than going into the intrigue details. Okay. Weather forecasting is as old as our species. Just when the history of mankind begins, when people started living together, started searching for food and all, they are looking at different aspects of the surroundings they are living in. Example, they will be looking at sky, changes in the sky, etc. And the history begins with the history of mankind. So, and it began as a non-mathematical activity. You might have heard of proverbs like this: red sky at night, sailor's delight; red sky in the morning, sailor take warning; clear moon, frost soon; halo around the sun or moon, rain or snow soon. So these are some sayings of proverbs that exist in olden days, just to remind you of the beauty when you look at the sky. And if time permits, I will be dealing with some ideas of different types of clouds and how do affect different mathematical modeling of the weather or atmosphere around us. And this is a saying by Theophrastus, Aristotle's student: if the breezes come from the east or south, rain is indicated. If from the west or north, cold weather will be happening. So this is generally true, but this kind of vague observational sayings are there in olden days. So what is weather? Weather can be defined as the condition of the atmosphere at any given time and place. Weather conditions are determined by 6 major factors. There are many, many factors, but mainly there are 6 major factors: air temperature, air pressure, humidity of the air, amount and kind of cloud cover, amount and kind of precipitation, cloud precipitation, and speed and direction of the wind. So these are some major factors which will be determining weather conditions. The 6 factors determining weather conditions result from the interaction of 4 basic physical elements: sun, of course, Earth's atmosphere, Earth itself, and natural landforms and Earth's surfaces. So these are some parameters that will be determining those major parameters. Weather condition patterns for any one region or for the whole planet can be charted on a weather map. So weather maps are there in very olden days itself, not in the very olden days, recent modern days. And now we have weather maps digitally made with the help of satellites and all. I will be going to the details later, containing information about all 6 of these factors. This information often can be used to produce a weather forecast, prediction of weather conditions at some future time. So it is transition from qualitative to quantitative and modern weather forecasting, how it is done. Some historical components I'll be looking at first of all, and I will be dealing with mathematical modeling of weather forecasting in between. So what do you require as the step 1? You need weather instruments with sufficient accuracy and reproducibility. So there are many equipments and instruments and nowadays modern gadgets required for sufficiently for predicting weather conditions with certain range of accuracy, at a required accuracy. So this is how we started actually from 1450 to 1750. So these are there. Galileo Galilei developed air-water thermoscopes. The first modern thermometer came as a consequence of it. Then Robert Hooke invented the anemometer to measure wind speed. Hooke in 1660, and later it was modified by Anderson in 1840. Torricelli devised the mercury barometer to measure pressure in 1644. But there was a problem: the absence of universal scales for basic weather parameters such as temperature. Means there is not standardization. So later came degrees Celsius or degree Fahrenheit for temperature. So standardization of units is a major turning point, major milestone in the history of weather forecasting. By the late 1700s, everything was in place. Decent instruments and universal scales have come in. The weather observing revolution was about to begin. Observing the weather became the high-tech craze of the period. So it was in later part of the 17th or first part of the 18th century that real things get happening. So a very famous experiment of Joseph Franklin, with the kite and all for modern weather prediction. That is, we can say, they started scientific experiments of weather prediction. And Ben Franklin has written a nice almanac in 1739 or 1743 rather, and that was the first record of weather forecasting. But there was major problems because of communication. Means we don't have faster communications. The communication channels available then were very slow. So we cannot pass the information to the required location where the disaster or where the storm can come in. So that was a major problem. But this is a radical shift in the invention process. The first practical electrical telegraph was built by Samuel Morse and Alfred Vail in 1837. So we can call that as the internet of 1840s. Telegraph, invention of telegraph changed everything actually. It was immediately recognized that telegraph made weather prediction possible. Joseph Henry in 1847 provided the vision. Extended lines of telegraph will furnish a ready means of warning the more northern and eastern observers to be on the watch for the first appearance of an advancing storm. So storm prediction was the first thing which had been done with the help of telegraphic communication. The weather telegraph revolution continued to some time. In 1849, the Smithsonian created a network of roughly 24 telegraph operators distributing daily weather reports from around the nation. A weather map, I told you weather map is very important, updated daily and based on telegraphic reports, was posted in the lobby of the Smithsonian Institution and Washington. Every evening Star newspaper published it in each issue. So means news reporting started off. Operational weather prediction begins later in 1854 rather. Admiral Fitzroy, he was the captain of the Charles Darwin's ship named Beagle, who was appointed as head of the new British Meteorological Service. In 1861, began issuing daily forecasts and storm warnings. But for everything, for every invention, every change, there will be some skeptic doubters actually. So this French physicist Francois Arago made skeptical remarks like this: whatever may be the progress of sciences, never will observers that are trustworthy and careful of the reputation venture to foretell the state of the weather. Weather forecasting will not be possible to a desired level. That's what his argument. But anyhow, pictures started changing later. This is a weather map published in 1880s based on the information accumulated from the telegraphic messages from different regions. So I'll later mention ensemble forecasting. Ensemble method of forecasting means one place will not be taken care of. The entire Earth's atmosphere will be scanned with the help of different satellites, with the help of international country-wise collaboration and all. So that's ensemble forecasting. But this picture was done with the help of telegraphic communication actually, available during that time. This is another atmospheric model. You could have read the words in that model: blue sky, cirrus. Cirrus is a kind of cloud actually. A dirty sky, muggy. That was the terminologies they used then to describe the atmosphere around them. So not refined. It was in its developing stage. So they used some non-refined words for expressing the atmosphere around them. Yeah, now I will come into what is called the mathematical side of it, numerical weather prediction, NWP in short. So the picture says that the atmosphere will be, you can see the green colored thing. The green colored thing is the atmosphere around that Earth. That will be divided into plenty of smaller grids to, means actually the supercomputers, I'll show you the computers used for analyzing data from each of the grids, that grid lines collected and analyzed. So, so the dimension of the parameters will be, means nowadays with the help of supercomputers can be done 10 raised to 8 such data information can be processed. That is the latest development actually. So this is the, or what is it, broad outline of the NW process. First, we'll gather observations with the help of the available technology. Then we'll assimilate all the data thus gathered. Data assimilation will be taking place. Then mathematical modeling, the already set up computers with the help of numerical computational powers will do the numerical weather predictions. Then after that, we'll have a result, but forecast post-processing. We'll have a forecast, we'll post-process it later, and then only it will be issued for public forecast. Then again, public opinion will be taken. What means again, it will be reviewed based on the expected outcome. So these are some of the applications. There are many, but I have listed only a very few applications. Air quality checking modeling, climate modeling, ocean surface modeling, tropical cyclone forecasting, wildfire modeling. So wildfire is a major issue nowadays. So such modeling can be done with the help of numerical or weather forecasting prediction techniques. Okay, let me go into some details of NWP. In the daily operation of weather forecasts, powerful supercomputers are used to predict the weather by solving mathematical equations that model the atmosphere and oceans. Okay, here I want to stop for a while, because right from the school days, every child who is loving mathematics will be asking either to her or himself that what are the applications of mathematics? Is there any application? And nowadays you might have seen some trolls. What is the application of a plus b whole square? I'm by hearting it, and I don't see any application for that. But that is not like that. Everything in mathematics will be applied somewhere. So there are plenty of partial differential equations, numerical mathematics involved, computational techniques. But I don't claim that mathematics alone do this one. Mathematics, along with physics, chemistry, atmospheric science, whatever it is, latest developments in the knowledge arena will be combined together. They all sit together, not in a compartmentalized world, but linked together, and they will do things to serve the humanity. And you could see at the end, I have a slide showing a research paper where the economic impact of this kind of forecasting is much, much higher. That I'll show you later. In this process of numerical weather prediction, computers manipulate vast data sets. Oh, yes, this is another area where youngsters have to get in. Nowadays, there are courses dealing with data analysis, artificial intelligence, machine learning, Internet of Things, many other things. New knowledge are being incorporated into the repository of knowledge. So that kind of things should be learned, not from the classroom. Sometimes classroom or curricula cannot provide you things. And you see nowadays, the classroom is very much limited. The classroom is wide open with the help of Internet of Things and all. So you have to look beyond the windows of the classroom and assimilate as much skills as possible to be a person apt or capable of living in the what is coming decades. So there are great challenges. That challenges can be suitably faced with the help of acquiring more knowledge. So data analysis is another very important major area where you have to focus your attention. So new NWP manipulate vast data sets collected from observations and perform extremely complex calculations to search for optimal solutions with a dimension as high as 10 raised to 8, 9. Now, with the help of new inventions, it is getting higher and higher. Supercomputers are looked from a different angle by the researchers, and they increase the capability of the calculations and all. The idea of NW was formulated as early as 1904, long before the invention of the modern computers that are needed to complete the vast number of calculations in the problem. It is in the year 1904, actually, Louis Fry Richardson and William Bergnes to produce by hand a 6-hour forecast for the state of the atmosphere over 2 points. After 1904, it took 16 years again, and there were no computers, and the numerical computations was done with the help of hand, and 6-hour forecast they have done with the help of efforts for 6 weeks. In the 1940s, late 1940s, a team of meteorologists and mathematicians led by John Fonneman, another brilliant mathematician and physicist, he had his role in many branches, and Jules Charney made significant progress towards more practical numerical weather forecasts. By the mid-1950s, numerical forecasts were being made on a regular basis. So, several areas of mathematics play fundamental roles in WB, including mathematical models and the associated numerical algorithms, computational non-linear optimization. So optimization techniques will come into play. Numerical algorithms will take care of it. Mathematical model building involving partial differential equations and all. In very high dimension, huge data sets manipulation and parallel computations. So parallel computations will be that area will be looked after by the computer experts. Data sets manipulation, of course, an area where mathematics students can play a greater role for data analysis. Statistics and mathematics can do a lot of things. Even after decades of active research with the increasing power of supercomputers, the forecast skill of numerical weather models extends to about only 6 days. Now also, we cannot, with accuracy, greater accuracy, cannot predict weather conditions beyond 1 week or so, but predictions can be done for long-term and short-term basis. And if you are predicting, if you have seen your mobile that today there will be a rain at Iritty at 3 p.m., means it is nowcasting. It is called nowcasting. It means forecasting for a shorter range. So nowcasting can be done because all the information will be almost available. Forecasting is done for more than 1 day. So forecasting, even using more sophisticated techniques available just now, cannot be subject to the present availability of the information, cannot be extended beyond 1 week or so. Improving the current model and developing new models for NWP have always been an active area of research. So here is another challenging area where the youngsters should jump in. Means, can we have model which can be fitted, which can be used for predicting even 1 month long weather forecasting. So that's the challenge that you have to take up. Operational weather and climate models are based on Navier-Stokes equations. It's famous equation, Navier-Stokes equations in thermodynamics and fluid mechanics and all, coupled with various interactive earth components such as ocean, land terrain, and other things. Many models use a longitude, spherical grid. I have shown that figure. It's logically rectangular structure, orthogonality and symmetry properties make it relatively straightforward to obtain various desirable accuracy-related properties. On the other hand, rapid development in the new technology of massively parallel computation, also I have already mentioned. So the numerical weather forecasting require a model where the atmosphere around us will be divided into spherical grids actually, and the data will be connected from each of that grid with the help of powerful satellites now available. Yeah, another area where we fail miserably is incorporating initial conditions. And many of the students are familiar with initial condition problems, initial value problems. So in order to work a model, in order to set up a weather forecasting models, we have to begin with some initial conditions. So initial conditions must be generated before one can compute a solution for weather prediction. So we have to have some information in advance, and with the help of that, we will be predicting. So a priori we require some information. That's a requirement. We call such conditions as initial conditions. The process of entering observational data into the model to generate initial conditions is called data assimilation. So we have to collect data which can be put into the model, and it will be processed and we'll be getting predicted output. Its goal is to find an estimate of the true state of the weather based on observation, sensor data, and etc. So latest technologies are there. And prior knowledge, mathematical models, system uncertainties, and sensor noise are to be avoided as sensor noise should be avoided as far as possible. Yeah, nowadays space-time coordinates, 4D variables are taken into consideration. In this approach, means videos will be recorded rather than the pictures. So where the time component also will be recorded. In this approach, a cost function based on initial and sensor error covariance is minimized. Here and all statistical analysis can do a great role. And of course, atmospheric science and all will be doing supportive roles to have a better prediction. Another family of data assimilation methods is ensemble Kalman filters. Kalman filter is ensemble, I have already remarked, means instead of having an observation at one person having one model, different models are taken and their averaging techniques will be taken into consideration. That is ensemble forecasting. Okay, that I'll skip. Okay, this is where mathematics comes into play. Actually, you could have seen that famous your partial differential equations where fluid mechanics. See, another very interesting feature is that air is behaving just like water. There is a strong connection between fluid mechanics of air and fluid mechanics of water. So they behave almost similar, but there are some differences, but almost the behavioral patterns are almost similar. So equations involved in analyzing fluid mechanics with, for air analysis, the atmospheric science will be almost similar to that of water and all. So atmospheric conservation of momentum, conservation of energy, conservation of mass, these are all principles in physics which will be converted into mathematical equations using partials and differential equations. Yeah, these are called different wind forecast equations, continuity equation, temperature forecast equation, moisture forecast equation, hydrostatic equations. These are complicated, which I'll not be dealing with these equations in a separate interviewing way. I will be providing a textbook on numerical weather forecasting at the end that I will show you a good book where you can begin with. Interested readers can read that book and get much better information. Anyhow, just remember that partial differential equations describe basic conservation laws will be having a great hand in the modeling method techniques. I have already mentioned that in 1904 that William Berkeley suggested solving the primitive equations, and it can be used for predicting future atmosphere. This is how it is done. If you can observe the current state of the atmosphere, known as initialization, you can predict the future using the equations that describe the physics of the atmosphere. These equations can be solved on a three-dimensional grid. Now, I have told you there is a four-dimensional way of looking at it. Even though the space is three-dimensional, a time component also will be added into that, and four-dimensional data will be collected. Yeah. But in the early 20th century, numerical weather prediction was thought to be impossible to accomplish in reality. There were no faster calculating techniques, and they used mechanical calculators for that. In 1922, primitive equations, solving the equations on a grid using a finite, here numerical combination, finite differences, method of finite differences can, because we want to convert that continuous partial differential equations into discretized form, because computers can process only discretized data set. So even if you learn continuous mathematics, How to discretize is another way. Linearization of this thing and what is it? Changing that into discretized data set is another challenging area of research where you can do your, you can contribute much. Forecast are computed using mathematical equations for the physics and dynamics of the atmosphere. These equations are non-linear and are impossible to solve exactly as I said now. Yeah, these are some methods which you have to take care of. Therefore, numerical methods obtain approximate solutions. Different models use different solution methods. Global models often use spectral techniques for horizontal dimensions and finite difference methods, of course, numerical techniques for the vertical dimension, while regional models usually use finite difference methods in all three dimensions. For specific locations, we'll have model output statistics. I have already mentioned that statistics is a very important branch where it can be used effectively to model it in a better way. Use climate information output from numerical weather prediction and current surface weather observations to develop statistical relationship which account for model bias and resolution issues. Okay, bias reduction is another area. Dimensionality reduction is another area where what is a singular value decomposition of matrices and all will come into play. Dimensional reduction is an area where our syllabus will not have not just done any justice to that case. So that's an area where research is taking place. So some input must be given to the students by incorporating some elements of those areas into our syllabus. That's my suggestion for those board members in the universities. I've already mentioned that discretization is required. df by dx will be converted into its equivalent discretized form that will be fed into the computer, and the computer will do actions with the help of that discretized data set. Okay, this is another part of the history. I'll be skipping it. Okay, this is L.F. Richardson's model in the early period for practical NWP. Yeah, many things fail because of the data inputs. That was the case in earlier periods. You see, they will be, what is that, making observatory at mountain stations, kites and pilot balloons, limited aircraft observations. These are some of the techniques employed in the history of mankind way back for measuring pressure, temperature, and humidity. This is another thing, weather kite they call it, to gather some, what is this, precipitation rate, temperature and all. Not that sophisticated. It was used in earlier periods of weather forecasting. Yeah, this was a major breakthrough. This is called radio sonde. A radio sonde is a portable weather station lofted by a balloon. Another historical milestone in weather prediction, launched on January 7th, 1929. Actual things come up. Many major mathematical research areas have opened up with the help of World War II. Even though war is something which we won't be actually pressing for, but World War II has given us a lot of things, and 3D distribution of the atmosphere was possible with the help of extensive research with the help of that radio sound network. Also, during this period, digital programmable computers have come in. ENIAC was the first thing which programmable digital computers have come into the realm of weather forecasting. And this is the picture showing ENIAC, which actually took almost one huge, large room. That was the beginning, actually. This is the control room of the ENIAC. Yeah, first numerical weather prediction. If you could see, the second from the left is Funny Man, the man behind the entire activity. First numerical weather prediction science team. Yeah, took place in 1950 using ENIAC. And this picture they have developed with the help of that, with a map using computer. Later, faster computers came in, and it has given us better weather prediction models, and we have got other gadgets for observations, better use of observations, improved data assimilations took place. So the revolutions have started picking up. But there was another revolution that drove numerical weather prediction in weather observation with weather satellites. Okay, I've already mentioned satellites have been doing major role in giving us very precise data for analyzing. But the thing is that the data set has become larger and larger. The data has become a huge chunk of data that is there. So getting information out of it is a hectic activity. For that, nowadays we have data analysis done to churn out information, actual information out of this raw data. This is the Polar Orbiter satellite, TIROS, launched in 1960, only for weather prediction. First weather predicting weather data collection satellite. This is the first image, first weather satellite image given by that TIROS. And National Oceanic and Atmospheric Administration of USA, NOAA, has sent a geostationary satellite in 1974, and much better than the older versions. Now I have told you that we are using 4-dimensional data sets. Weather satellites now view the entire planet much more accurately than years ago. Numerical weather prediction uses some of the biggest computers on the planet. Our forecast models use the largest supercomputers and run on many processors simultaneously. This requires very fast code that is parallelized to do many things. So these are the Cray XC40 used by National Oceanic and Atmospheric Administration of USA, and research is going on. And this is what I have mentioned a few minutes back. There is a fundamental issue. Mathematician meteorologist Lawrence found that small errors in initial conditions can grow that forecast skill is lost at about 2 weeks. We cannot have longer term predictions with the help of the existing repository of knowledge. That is the point where the youngsters should jump in and do some research to make it much better, because we enjoy the fruits of knowledge that our ancestors have shared with us. Okay. Butterfly effect. I have already mentioned that even the fluttering of the wings of a butterfly can, in an Amazon forest, that's how it is described, in an Amazon forest, can change the prediction. Okay. A fundamental problem is all forecasts have uncertainty. So uncertainty has to be reduced with the help of probabilistic techniques. That is where we have the ensemble forecast. There is an approach to produce guidance. Weather forecasts need to tell users about the uncertainties in the forecast. What is the accuracy level that we can expect with the help of the data, information which we have. How accurate it will be. Sometimes പഴയ കാലത്ത് പറയാറുണ്ട് മഴ പെയ്യാനും പെയ്യാതിരിക്കാനും സാധ്യതയുണ്ട് എന്നാണ് പഴയ കാലത്ത് പറയാറുള്ളത്. പക്ഷേ ഇന്ന് കൃത്യമായിട്ട് കുറച്ചുകൂടി ആക്യുറേറ്റ് ആയിട്ട് നമുക്ക് കിട്ടാറുണ്ട്. സ്റ്റോമിനെ കുറിച്ചും ഭൂകമ്പത്തെ കുറിച്ച് പോലും നമുക്ക് ഇന്നലെ അഫ്ഗാനിസ്ഥാനിൽ ഭൂചലനം ഉണ്ടായി കുറെ പേർ മരിച്ചു എന്ന് പറയുന്നു. പിന്നെ പരേതരുടെ ആത്മാക്കൾക്ക് വേണ്ടി നമുക്ക് പ്രാർത്ഥിക്കാം. എന്തായാലും such predictions are required for saving humanity from disasters. Oh, yes, ensemble prediction is a technique where statistics play a major role in analyzing data. So I will not be dealing with that. That's an output, means the second stage of numerical weather forecasting. Yes, even more mathematics in weather prediction is required. Numerical weather prediction produces a future description of the atmosphere for all atmospheric variables on a three-dimensional grid. So now it is four-dimensional, I told you. We can apply statistical techniques to improve the forecast further. How we can correct for known past biases or errors. And that's what we call it as after we have this output, we'll be processing it. That's a step in numerical weather prediction. Yes, I have mentioned it. Machine learning is an area where research is very hectic, and there are some universities giving courses on machine learning. And this is a slide which I have seen in the YouTube dealing with a talk on machine learning applications for numerical weather predictions, where you can fed something to neural networks and it produces outputs in a much better way. So machine learning is an evolving what is the branch of discipline of knowledge. It is in the process of research, but there are courses, and you can have some courses from foreign universities in Coursera and all, and get ready for such actions rather than sticking on to the normal way of learning. Numerical weather predictions, as I mentioned, is the biggest of big data. A huge amount of data coming in each from weather satellites, radars, and other observing platforms, just like that the gushing water out of that gadget from that fireman. Huge amount of output from numerical weather prediction models. Moving and storing all this data is very difficult. Making use of this huge data stream is a great challenge. Now, at the end, this is the bottom line. Numerical weather prediction may be the complex and cooperative mathematical activity of our species, involves solving a complex series of partial differential equations and highly mathematical data assimilation and observations, requires worldwide cooperation. Yeah, here is where international level cooperation is required, because India cannot do on its own anything, because it requires information from other locations, from US, from England, from Middle East and all. So altogether, it will be giving a holistic picture. Otherwise, we'll be confined to ours. So international relationships are to be made much better of gathering observations from weather satellites and other assets from worth tens of billions of dollars, requires the use of largest supercomputers, involve sophisticated statistical post-processing of model forecasts, and there is much more progress to be made. And the last point is very valid. There is much more progress to be made, and we expect at least a few of the listeners to come up for learning atmospheric science and meteorology. And this is a Hindu report on economic benefits to farmers, fishermen since 2015. It amounts up to 19,000 crores per annum. Means using weather forecasts, they have gained this much. Which day is better for fishing, and which day or which season is better for farming and all. So that clear-cut information given to them will increase the productivity. So that you can see that report from the internet, written by Jacob Koshi. Okay, I have mentioned that new technologies such as Internet of Things, artificial intelligence, machine learning, everything should play hand in hand, glove in glove, so that we'll get better predicted model. Good news for monsoon-dependent India is that we are getting better at predicting. New technologies such as Internet of Things, artificial intelligence are helping meteorological experts to give better information to predict agricultural output and natural disasters. So this is a paper which you can get from the internet, which is a very important paper, Mathematical Modeling in Meteorology and Weather Forecasting, written by so many Russian and one Ukraine person, where the war is going on. Yeah, this is the book which you can start reading. For the beginners, you'll get a better pictures for fundamentals of numerical weather prediction written by Jean Coiffier. Yeah, something about certain courses available in India to learn meteorology and atmospheric sciences. There are diploma in meteorology, bachelors of science in meteorology, masters of science in meteorology, Tech meteorology and atmospheric sciences, Tech meteorology, PhD in meteorology. These are available opportunities. Diploma eligibility is means TET standard. Best colleges available for diploma: Punjab University, Patiala, College of Engineering, Andhra University, Visakhapatnam, Cochin University of Science and Technology, Cochin. I don't know whether they give diploma. We have to inquire it, but this is taken from the internet. Indian Institute of Technology, Kharagpur. I told you this is an institution where the prominent program of that institute is atmospheric science. Bachelors of Science in Meteorology, 10+2 with Physics, Chemistry, and Mathematics is the basic qualification. ABB College, Government College, Jangwan, Orissa University of Agriculture and Technology, Bhubaneswar, Shivaji University, Vidyanagar, Maharaja Sharaja University of Baroda, Vadodara. So many more you can have. These are some best colleges. Masters of Science in Meteorology and Meteorology courses in India. BSc Physics, Chemistry, Mathematics also is included. I have left it. ABB Government College, Jangwan. Oh, yes, the list is describing only best colleges. Tech, of course, is there. Indian Institute of Technology, Kharagpur again comes at the top. Tech is there. Indian Institute of Technology, Tropical Meteorology, Pune. Cochin University of Science and Technology, of course. You should have scored a valid GATE score, so you should prepare for GATE score and other high-level entrance examinations. PhD in meteorology is another area where youngsters can aim for. Job prospects, we have Indian Meteorological Department, IMD, Industrial Meteorologists, Physical Meteorologists, research meteorologists. You can have professors in some great institutes, in Navy, Air Force, Weather Consulting Organization, aircraft and missile manufacturers, agriculture planning divisions. These are various opportunities where you can have after having done a course in meteorology or atmospheric science. This is another important course, Masters in Climate Science and Technology, offered by Indian Institute of Technology, Bhubaneswar. Actually, it is giving an idea about dynamics of atmosphere, ocean and their interaction, dynamic and synoptic meteorology. So it's a beautiful course, which you can look at the details in the corresponding website. And now, if the time permits, I'll be briefly looking into that aspect also. Can I have 5 more minutes?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. What are clouds? So we are fond of looking at the sky and we see different types of clouds. And you might have learned in your school classes, there are major 4 types of clouds. And clouds are large groups of tiny water droplets or ice crystals that cling to pieces of dust in the atmosphere. Clouds are so important to the Earth's weather that meteorologists also study the clouds and their movement. In fact, without clouds, it wouldn't rain or snow. So rain is possible only because of the formation of the clouds. They come in all different shapes and sizes, and due to depending upon the shape and size and the height where they are settled, we will be classifying the clouds into several classes. Some are really low to the ground and some are way high up in the sky. Scientists have developed a system to classify the different types of clouds. Each cloud you see can be put into one of the many categories based on both the general shape and how high up they are in the atmosphere. And this table will give you different cloud names and where they are settled. And altocumulus, cumulus, cirrus, and stratus and nimbus. These are the major classification, and the hybrid combinations are there. Altocumulus, altostratus, cirrus, cirrocumulus, zero stratus, cumulonimbus. Cumulonimbus clouds are now available because of the this condition. Weather is rainy seasons, we'll have cumulonimbus clouds. You can have pictures of many clouds in the internet, beautiful pictures, and they should arouse some interest in learning atmospheric science and meteorology. So this is a table which provides, and more details about you can have from this beautiful video from the YouTube on different types of clouds. Link you can just note down, and that's all. Thank you.
Thank you, sir.
If you have any doubts, you can ask, but I don't think that I'll be able to answer all the questions because even though I am very much interested in atmospheric science and meteorology, I'm a beginner to that and I'm just reading the things, but questions are almost welcome because it will be something for food for thought. So you can ask, and if there is something which I could share, I will share. Another thing is that I have an appointment for the for my wife's skin problem at in an hospital, Srijan Hospital. So I'll be available here for 10 more minutes.
സാറിന്റെ സെഷൻ വളരെ ഇൻഫോർമേറ്റീവ് ആയിരുന്നു. കാരണം ഇപ്പോഴേ ഫൈനൽ ഇയർ വിദ്യാർത്ഥികൾ പഠിക്കാൻ പോകുന്ന പല കാര്യങ്ങളുടെയും അപ്ലിക്കേഷൻസ് മനസ്സിലാവുന്ന രീതിയിലാണ് സാറിന്റെ ഡിസ്കഷൻ ഉണ്ടായിരുന്നത്. കാരണം ഡിഫറൻഷ്യൽ ഇക്വേഷൻസിന്റെ അകത്ത് വരുന്ന ഇനീഷ്യൽ വാല്യൂ പ്രോബ്ലംസ്, ഇനീഷ്യൽ കണ്ടീഷൻസ്, അതെങ്ങനെ നമ്മളുടെ വെതർ പ്രഡിക്ഷനിൽ ആവശ്യം വരുന്നു എന്നുള്ളതൊക്കെ സാറിന്റെ ഈ ഡിസ്കഷനിൽ വന്നിട്ടുണ്ട്. പിന്നെ നമ്മൾ പഠിക്കാൻ പോകുന്ന ന്യൂമറിക്കൽ ഡാറ്റ, ന്യൂമറിക്കൽ അനാലിസിസ്, അത് എന്തിനാണ് ഉപയോഗിക്കുന്നത്, അതിന്റെ അപ്ലിക്കേഷൻ എന്താണ്, അതിന്റെ വെതർ പ്രഡിക്ഷനുള്ള അപ്ലിക്കേഷൻ എന്താണെന്നൊക്കെ സാറിന്റെ ഇന്നത്തെ ഈ ഡിസ്കഷനിൽ വളരെ വിശദമായിട്ട് പറഞ്ഞു കഴിഞ്ഞു. മാത്രമല്ല നമുക്ക് അറിയാം അടുത്തത് തന്നെ നമ്മൾ 5G ഇതിലേക്ക് പോവുകയാണ്, നെറ്റ്വർക്ക് ഒക്കെ മാറുകയാണ്. അപ്പോൾ അതൊക്കെ വെതർ പ്രഡിക്ഷന് വളരെ ഫാസ്റ്റ് ആയിട്ട്, കാൽക്കുലേഷനൊക്കെ വളരെ ഫാസ്റ്റ് ആയിട്ട് ഡാറ്റ ട്രാൻസ്മിഷനൊക്കെ സഹായിക്കും എന്നൊക്കെ പറയുന്നുണ്ട്. അപ്പോൾ സാർ അതിന്റെ ഒരു ഹിസ്റ്ററി വളരെ നന്നായിട്ട് തന്നെ ഇവിടെ എക്സ്പ്ലെയിൻ ചെയ്തിട്ടുണ്ട്. അപ്പോൾ ഞാൻ എൻ്റെ പ്രിയപ്പെട്ട വിദ്യാർത്ഥികളോടും അതുപോലെ ഈ മീറ്റിംഗിൽ പങ്കെടുത്തിരിക്കുന്ന മെമ്പേഴ്സിനോടും അവരുടെ സംശയങ്ങളൊക്കെ ചോദിക്കാൻ വേണ്ടി ഞാൻ അവരെ ഇൻവൈറ്റ് ചെയ്യുന്നു. താങ്ക് യു.
Thank you, Biju.
Good afternoon, sir.
Arada, you Arada. Okay. Okay.
Sir, sorry, I am Ansha K of BSc Mathematics student in Mahatma Gandhi College.
Okay, okay. Anusha, please tell me.
First of all, let me tell you that your class was really amazing and we are able to understand the topics very clearly. And for me, it was the first time about the class. Sir, my doubt is, can you please explain the opportunities in research in this field?
See, I have at the outset itself, I have told you that after getting JRF, Junior Research Fellowship, way back in 1993, immediately after my PG, I got JRF, and there were two letters for me. One from IIT Bombay. They invited me for joining in a research program on digital image processing, and the second one was from IIT Kharagpur, doing for research in atmospheric science. But I couldn't join those institutions, great institutions. That was a sorrow for me. But I reached to some other places, thanks to the Almighty. So anyhow, atmospheric science for doing research, the first and foremost place is IIT Kharagpur. So you aim for that. You write your what is that UGC CSIR examination and get a JRF. Write a letter to the director of the Department of Atmospheric Science at IIT Kharagpur. And if there are some projects, there will be a plenty, because IIT is a place where everybody will be having a lot of opportunities, and you have to aim for that. And IIT Bhubaneswar is another important place where you can go for climate studies and all. And IISCs, of course, and ICES and all will be providing opportunities. But for reaching there, you have to start now itself. But for gaining all the techniques for getting through clearing through the examination, clearing the competitive examinations and all. And because filtering out is the major principle of these examinations. So you must aim for that. So good luck.
Okay, thank you, sir.
Anybody else? See, I haven't gone through all the intricate details of mathematical techniques, because I have already mentioned that this is a group, heterogeneous group, where it comprises of first year students to the experts. So I must focus only on the general aspects. And if time permits and if my reading goes on, I'll be able to have another session where I can deal with some mathematical concepts in a deeper way. Because it demands knowledge in fluid mechanics, the dynamics of some physics related ideas are required. So partial differential equations and Navier-Stokes equations do a greater role. So it's a branch having many requirements from many branches. So I'm happy to hear that I have been bored for this 1 hour. And if no questions are there, I think it is time for winding up the session. And I request Dr. Biju to take the initiative regarding that.
Hello, Shahul sir.
Okay, Parnulu.
Okay, sir. Session വളരെ ഇൻട്രസ്റ്റിംഗ് ആയിരുന്നു. കുട്ടികൾക്കൊക്കെ വളരെ ഹെൽപ്ഫുൾ ആവുന്ന രീതിയിലാണ് സാർ ടോപ്പിക് പ്രസന്റ് ചെയ്തത്. കുട്ടികൾക്ക് ഒരു ഓഫ്ലൈൻ ക്ലാസ് സാറിന് കിട്ടിയിരുന്നെങ്കിൽ എന്നവരെ പറയുന്നത് ഞാൻ കേട്ടു. അപ്പോൾ എപ്പോഴെങ്കിലും സാറിന് സൗകര്യപ്പെടുമെങ്കിൽ നമുക്ക് ആ രീതിയിലൊരു ക്ലാസ് കൂടി സാർ അറേഞ്ച് തന്നാൽ നന്നായിരുന്നു, സാറിൻ്റെ സമയത്തിനനുസരിച്ച്.
ഓക്കെ നമുക്കത് നോക്കാം. എന്തായാലും അത് കാരണം താല്പര്യം, അതാണ് നമ്മൾ സാധാരണ പറയുന്നല്ലേ, നെസസിറ്റി ഈസ് ദി മദർ ഓഫ് ഇൻവെൻഷൻ എന്ന് പറയാറുണ്ടല്ലോ. അപ്പൊ താല്പര്യം ഉണ്ടെങ്കിൽ നമുക്ക് അത് സംഘടിപ്പിക്കാവുന്നേ ഉള്ളൂ.
Okay, sir. Okay, thank you. Now I invite Varada, student of 3rd BSc Maths, to deliver a vote of thanks.
Good afternoon to one and all present here. We all know that June 5 is observed as We all know that June 5 is observed as World Environment Day. I know that a few days have passed, but it's better late than never. As dutiful citizens, it is our responsibility to conserve nature. Our reckless use of resources without protecting it may have a deteriorating impact on the environment. The seminar presented was on the topic Modern Weather Forecasting, a Mathematical Perspective. We, as the students of mathematics, found it very interesting and highly informative. I take this opportunity to thank Dr. Shahul Hameed for arranging such a wonderful session. I also take this
Thank you,
opportunity.
Varun.
I also take this opportunity to thank Dr. Bijmohan R., Head of Department Mathematics, MG College, Iritty, for his support. I also thank Ms. Priyanka, convener, Bhoomithrasena Club, and all faculties and students of our college and various other colleges for participating in this session. Thank you.
Thank you all for giving me again an opportunity of interacting with youngsters in particular, because they are to be ready for taking challenges in the future. And I hope I have done a little bit of justice to in this regard by sharing some of the informations where you can really look into, and interest will take you much ahead. You can go through the websites, starting from the Wikipedia information and to other books, which I will be sharing with Priyanka and all. That book is a good book to start with, and you can have your own contributions later for as a service to humanity. And I wish all you the very best. Thank you. Thank you.
Thank you, sir.